Hi, good morning. Thanks so much for joining me in my shop here on November 2nd, 2021. Ooh, you said what year it is. And I'm about to start on this award-winning radio. Well, it's actually the award itself here. So this radio was gifted to me by one of my customers. Just tossed it at me as they picked up their radio and said, hey, maybe I want this. And their only comment was, the clock works. So we're going to find that out pretty soon. So the interesting thing about this is a radio mounted on top of this wooden block here, turned into an award radio given by the Orillia LC Club. LC Club Champions. LC Club. 1956. 1957. That was a very good year. Won by Pam Behan, Ruby Ingram, Mabel Dilworth, and Stuffy Reed Skip. Stuffy Reed Skip. I wonder if this is for curling. Donated by the West End Radio Limited. Well, West End Radio Limited. Well, I don't think there is such a company here anymore, but back then, this must have been the radio shop or one of them here in Orillia. So clock radios at this, this age and this vintage, generally the clock doesn't work. Generally the clock knobs are missing. You can see two of them are missing. For some reason these little knobs just go missing a lot. It has one of them though, that's good. Has a second hand, which is kind of good. Looks kind of bent. How would you ever get that bent? Has a glass front, and all the writing is on the back. No, these numbers are on the front. Yeah, I think it's on the front and the back to give the numbers a very particular look. Yeah, I think they're printed both front and back, which is very unusual. Let's see what it actually says on here. Sylvania Analescent lamp. Are there some letters missing there? Incandescent. Well, no. Analescent. Never heard of that. Telechron movement. Well, my understanding is just an electric motor in there that is synchronous with the 60 cycles. And that's how it was. So I'm not sure what a technochron would be. Okay, let's turn the... I guess this is tuning here. No. Oh, this is tuning with no string. I think that's what this is. Where's the volume control? Oh, here it is. Snuck it around the side here. Well, it's got the wrong color knob on it. Oh, that'd be on. That would be off. And then this would be the volume. Okay, let's turn it off. I'm going to plug it in and see if the clock really works. But first, we should really take a look inside. So they've crossed out 25 cycles here and written in 60 beside it. So what this may indicate, not necessarily, but it may indicate that the clock has been changed in here. Now after the Second World War, much of the power here in where I live in Ontario was 40 cycles, 25 cycles and 40 cycles? 40? Where did I get that from? And the government put out a big program of changing everybody's clock motors. Yeah, actually changing people's clock motors to a a motor that will run with 60 cycles, because the clock motor, it's trying to keep track of time. The 60 cycle thing is actually kind of handy in that respect. So a truck would pull up on your street, and I guess you'd know it was coming. Guys from the government, the power companies basically, would come to your house. Where are your clocks? I got one on the wall, I got this one here. They would take your clocks out to their trucks. They would take out the old motor, and they would have a new motor to put in it. I guess they must have had a load of them in different kinds of motors to do that. And uprate your clock. At the same time, the power crews would be changing the wiring to your house. They would have installed the new 60 cycle distribution system alongside the old 25 cycle system. And at some point they would just drop new wires to your house from the new system and take away the old wires, and eventually, when all was done on your street, they would come and remove the old system completely. And you'd have a nice new 60 cycle electric system, and this very much employed people after the Second World War. It was a big part of it. So, you know, it's one of those two bangs for $1. People are employed usefully, and the electric system was upgraded. 1956, I really thought that happened earlier, but maybe not. Of course, it happened at different times in different places. What was going on in the United States, I'm not sure. Probably something similar was happening in the United States, maybe even other countries too. Let's take the back off. See what surprise this has for me. Surprises. Oh, there's a whole pile of faded writing here. Oh, is that writing? Why, it would look like a vast amount of writing on the back of this is all faded out. Miscellaneous. I think it says miscellaneous control. That's a little vague, isn't it? Appliance outlet. It gives 1100 watts, it looks like. So you shouldn't really plug your iron into one of these things. Well, I don't know how I could recover that. Maybe with some photography or something to recover all the writing, but it's a huge amount of writing back here. I mean, what do they have to say on the back of a radio like this? Okay, is there an antenna on the back of this? Yes, there is. As usual, these are really quite awkward. The antenna wires are never really long enough. Often these are broken off and bad things have happened to them. The string. That's right. I half forgot the story here. The fellow called me up the other day and said, "Can I buy a tube from you for my radio? This is the radio." I said, "Sure." Sold him a tube. Not much money. Phoned me up a little bit later. I put the tube in the radio, but the radio still doesn't work. Would you like the radio? So I gave him his money back for the tube, and now I have the radio. He was thinking, well, he looked in the back and could see one tube wasn't lighting, and thought, well, I just replaced that tube. We should be in good order. Well, you know, maybe that'll work. The strange thing about it is he described the radio to me, and I told him I think it's a 5-tube radio, and because of that, if one tube doesn't work, well, I didn't tell him this, but if one tube doesn't work, none of the tubes will work. I wasn't quite sure what he was up to. I think there's a good chance the tubes are in the wrong place. I think there's a good chance we got the wrong tubes. So I think there's a really good chance we should not try turning this guy on. And I think he told me he plugged the tube in that I sold him, and it lit up. So I don't know. That story doesn't hang together all that well. It can be very tricky to see these. The reason I think things are a little wrong here is it looks like the rectifier tube is down here at this end of the radio. You would tend to put it down here, closer to the outlet and stuff. There's no guarantee of that. Here's the old string. a bit of it anyway. There's the spring. I think I can see. I think I see the pointer and everything hanging in there. Let's go see if we can fish it out. Kind of fallen down in front of the radio. Well, we're going to take the radio out. No, I'm not going to plug this in. There's too much. Even if I pull these tubes out, oh, I could. Now let's just take a look. Is the speaker and the clock, are they all going to come out together, or is something going to be left behind? Is the clock going to stay behind? Nice green color. I like that. Yeah, I like the color. Not so much this knob. Wow. It's just a little strange that this metal part is recessed behind the hole. That's not strange. What's strange is this one is not recessed. So see how the knobs have long collars on them. That's to reach inside the cabinet to get to the metal knob. And the reason for this is a dangerous radio. I warned this fellow that I think he's working on a dangerous radio. So you don't want any metal parts that are connected to the radio itself protruding. That would include these knobs. But here's one protruding. See how the screws from this, from holding the back on, which protrude, right? The screws can be touched, go into these wooden blocks here. And I'm sure it's done in a fashion so that this screw doesn't touch this chassis. This is all from the days of no polarized plugs. Yeah, no polarization on there. Plug this in this way or that way. And without going into the details of the hot chassis problem, these radios can be dangerous because they can fool you a lot. You could put your voltmeter on the chassis here and read the voltage to ground, have this plugged in. Read, I'm going to guess, it depends on the radio, I don't know about this one, but it might read a full 120 volts. Alarms should go off at that point. You can pull the plug out and turn it around, plug it in, and now you're reading 0 or very close to 0. Go, well, that's safe, I'll just make sure the plug stays that way. And then proceed to turn the radio off. And if you got out your voltmeter, you'd start reading the 120 volts again. This is the insidious part of these radios. You can't really make them safe unless you put a polarized plug on and thoughtfully connect the power cord inside the radio. At least that way you can make it so that when you turn it off, the chassis has no voltage on it. But I think, and I'm just talking off the top of my head now, if you turn it on, I think you're back into the voltage on the chassis problem. These are inherently dangerous radios. What's this guy for here? It's like oh, this was the one that had the weird statement on it. Panelescent control. Panelescent control. So something to do with the light. Something very mysterious about the way this is lit. Okay, so getting it off, I think we have to take it off this fantastic base here. With the beautiful gold-plated award plaque on it. So how did he do this? Now I just as soon have this back on it. We'll leave it like this. We'll flip it up this way. So the green color makes this radio a little bit interesting. So they just countersunk these holes way up to the top, and then screwed in probably straight into the chassis here. So chances are, I'm sure it looks that way. I released this screw, the chassis is going to be loose right in the cabinet. Okay, what are the chances? Probably pretty good. Maybe not. What's in there? Probably a flat. Yep. Okay. This might be the first time it's been off its base for a long time. West End radio. So I live in the West End of Orillia. I guess what would have been called the West End of Orillia. So I'm imagining these screws are just going straight into plastic. And when the radio's this old, a lot of the plastics become brittle. These screws can easily break it. Screwing it in particular, of course. Pretty tricky to fix that up after you break it. Okay, I think those are out. Let's see if I can get them out with this. No. It's a magnet. Doesn't fit in there. How about this guy? They don't want to come out. I probably just pinned a little bit. Right off, no problem. Ta-ta-ta. There it is. The wooden plaque revealed. Those don't look like the kind of screw you put into plastic. They look like the kind of screw you put into your deck. This is a solid hunk of wood here. Okay. Now it looks more normal. I should be able to just get the case out. I'm looking for what to hold on to. Let's see. Did you see everything loose? Everything's coming out. Nothing's coming out. It's another screw. Secret screw. The secret screw. Looks like a red square. Good old Canadian screw. That also does not look like a screw that goes right into plastic. These holes look drilled. Like they don't look original. This does not look original. So this radio held in with one screw? That doesn't sound very likely either, but that's what it looks like. There's some little bumps here to kind of hold the chassis. And maybe once you get one screw pulling it down, it's all done. Who's coming out now? Did I forget? Oh, this is caught here. There's a very long volume control in there. May not be original. This antenna's causing me trouble. Probably just mount this right back onto the radio. Probably the best thing I can do, certainly at this point. Or the wires will get broken on it. There it comes. Out it comes. this stuff is here. Something towards the front. Actually, it's all over the place. Don't know what that is. So I'm looking for cracks. There's a crack here. There's almost always cracks in these things. Cracks in the corners, anywhere there might be stress. Crack right through the bottom here. Right through this hole where the screw is put in, putting stress on the plastic. This is what makes airplanes crash. Not anymore, luckily, but in the early days, cracking of materials under stress wasn't well understood. And to have a few planes crash. I love the front panel. Auto. This says something more on it here. Auto off manual. 15, 30, 45. So that's, you can set it to play for that length of time. And you go to bed. Looks like maybe a crack here. Crack there. There's a crack here. So lots of cracks. But no pieces missing, and at a glance you can't really see those cracks. Even this one's a little hard to see up here at a glance. It's been washed many times. You can see all the scratch marks on it. See if I can buff this guy up eventually and make him look like new. I'm going to set it aside. Oh, wrong thing. Just check to see if there's anything written underneath. Sometimes a schematic is glued underneath. Here we are. What do we got here? So we have, looks very different once it's out. Very white background. Here's the pointer. That's, yeah, well, that's how it's supposed to be bent. It's a little curious. This is actually quite curious. So this is made to slide. Just look down a little bit here. This is made to slide on a metal track. It's got the pieces here. It's extremely long. It's bent in a funny shape. It's painted all down here where it would never be seen. Then the backside, which has been flipped up, has been painted. Well, it could be they bent this in shape, then when they painted it, the paint went wherever it went, and they didn't care as long as they got it right on the front here. This is the only part anybody sees. Do I have to hang like that? Oh, there's a surface to slide on right here. Okay, that's how they did it. Very good. I'll put that with the other string parts over here. So, sure looks like that motor could use a little bit of oil, but I'm not going to jump in with oil right away. Everything's turning and moving. Well, I think we should take a look underneath. Now I can flip this guy right upside down. Just kind of handy. Look at that long control. Put my fingers through the speaker. There we are. Okay, warning bells went off already. This radio. Did you hear the warning bells? They're pretty clear in my head since I saw this thing. This guy right here. So this is got various names as far as I know. I could call it a package. Sometimes it's called the integrated circuit, but that's, I think, not quite the same as the modern use of the term integrated circuit. But in here is some capacitors and resistors. Typically, these things were made to go in the audio section right around the detector, and contained a series of components that just about every radio would require, like this. Every 5-tube radio is going to require a little bit of a network of capacitors and resistors. So if they could manufacture it into this package, they could sell the package, and the radio designer, wow, it's just one part going in instead of a bunch of parts going in. Save a bit of money. So there's 2 wires here that are virtually short-circuited. These bare wires. Not now, they're not. I think they were just not quite in contact. And you can see on this wire here, this kind of orangish wire, a lot of mildew growth on it, or whatever that is. Something is growing on it. Same thing here. It's possible it's a crystal of some sort, not something alive. The other wires don't have any of it. Do all the capacitors look original, or do they? So you've got this wax guy here, got a molded one here of one manufacturer, another over here of another manufacturer. This one, this large one here, is going to the chassis. So that sends a bit of a message. And I look through now, what else is hooked up to the chassis? Just at a glance, you know, there could be missing things. I don't see anything else connected to the chassis. I'm looking around the tubes to see if any of the tube pins are soldered down to the chassis. No. No. So probably find a resistor in parallel with this capacitor, which I believe what this is really doing is it's connecting the chassis into the B- line to drain the chassis from any signals that might be in it. Otherwise, without this capacitor, the chassis is just a big piece of metal sitting here with this radio built in it, and it'll act like an antenna. It'll pick up stuff, unwanted stuff, convey stuff from one part of the radio to another. So they drain it out, but you don't want to put a wire to the chassis, because this point ultimately is connected to one of these prongs. Well, you plug this in one way, and this is neutral relative to your hydro system. Plug it in the other way, yow, 120 volts there. So you use a capacitor to drain out the radio signals, but maintain some level of impedance, would be the right word, between the chassis and here. For the guys like me, when I was a kid and didn't understand any of this, and would grab onto this thing and be poking around and hook it up to other stuff, sparks flying and everything. The idea is you can't conduct enough current through the capacitor to electrocute yourself to death. You're just going to get a lift, basically a warning. That's really what it is. It's a very important capacitor. That's why I'm dwelling on it. Important observation: what is connected to the chassis, if anything? See the big capacitor here? This frame has to be bolted into the chassis. So how's that done? Well, there's a rubber strip I can see under here. So it looks like this is mounted on a rubber piece of rubber, and then somehow screwed mechanically to the radio chassis in such a way that there's no conveyance of electricity between the chassis and the frame of this. This means from time to time, maybe all the time, there's a potential difference between this and this. Again, it could be 120 volts, and this is one of the worst shocks I've gotten from this kind of situation years ago, where I got my finger in here somewhere. I think the radio may have been switched off. I'm thinking it's safe. No. And you're getting it straight from the outlet, basically, 120 volts, and that's enough to kill you. Don't kid yourself. People die from 120 volts. I believe the lowest recorded death by electricity was 50 volts. And that's why the telephone system, at least the old telephone system, ran on 48 volts, except double that to ring your phone. And you get 96 volts to ring the phone. but the rest of the time 48 volts, so that made all the telephone workers relatively safe. So the thinking was back then. Obviously it's a factor of, how well you are grounded, what your conductivity, how much contact you make with the item. There's lots of other issues about whether you're going to get killed or not. So this is a little capacitor here. It's got Hunts written on it. Hunts capacitors of that color, it's hard to see in the camera, that color and that vintage, the age of this, gotta go. Gotta go, gotta go, gotta go. Here's another paper one here, gotta go. What about the capacitors in here? This is the problem. And the resistor in here too, or there's a couple of them probably in there. They could all be defective. There's a good chance one of these capacitors in here is defective. We can't go down to the store and buy one of these. I mean, these are individual, pretty much for the radio involved, I would guess. So one way around it is to recreate this only using discrete components. That means you're going to do the work that the designer was avoiding in his factory when he chose this thing. So it's a little bit tricky to figure out what's what. Sometimes I've been lucky and I've been able to, because a capacitor is shorted inside, I've been able to cut one wire and stick a replacement capacitor outside, and the whole thing worked again. So I don't know. We don't know there's anything wrong with it. Just anticipating what's coming down the road. If we look at where the outlet wires come in, one here. See right in the vicinity of them, a fairly large wattage resistor. And it looks fairly discolored. Hard to say what these bands are. It looks like brownish, a little more brownish, and very brownish. So I don't know what that is. Probably this is around 200 ohms or something in that range. The other resistors all look pretty good, but that doesn't guarantee anything. So this is the filter capacitor here. It looks like it's the original. I'm saying that because I can see the metal band that's locking it in. It's in very tight. So almost certainly this has to be replaced. These radios have weak power supply filters just based on capacitors. Usually 2 capacitors with a resistor. In between, if you understand my circuit diagram here, this is probably the resistor that's in between. You see a black wire here, nothing coming out the bottom. Black wire here, blue one going over here, red one going over here. That doesn't tell us too much. It says on it 40 and 40 at 150. So I've got 50s at 160 volts. I can replace this with no problem. Yeah, replacement of these things, you have a choice. You can remove this and you gain all this space. Then you can stick your new capacitors in that space. The other thing you can do is you can cut the wires off if they're not too stiff. These are probably pretty stiff. Cut them off close to the capacitor, and then you have these little bits of wire already installed in the radio. You've got to make your capacitor connections to it. So rather than cut them all away, they might be useful. Especially the long black one here, which feels fairly flexible. I don't hear it cracking. It's stiff, but it's not shot. A lot of these other wires in here, if you were to bend them, well, you know what? A lot of these wires are cloth covered, which is a thumbs up. The cloth tends to last a long, long time. Underneath the cloth is some rubber insulation or something like rubber. That doesn't last. So you can bend one of these wires and you can hear the insulation cracking underneath. But the cloth cover is still there. Best thing to do is try to leave the wires alone as much as possible. In the worst case, insulation can just literally crack off and fall off. It's just so bad that you have portions of wires bare here and there. And you can see situations like right down in here. I don't know if you can see it, but this wire I've got my finger on is crossing a bare wire, and they're right in contact. Well, it's cloth covered, so there's really no problem there. But if this were just a rubber insulated or whatever the material is they were using, that rubber could crack, especially right in the contact point, give you a short circuit. You're working away, you're flexing things, crack, crack, crack. You're installing short circuits without knowing it. So that's a road you do not want to go down unless you're really prepared to do the whole restoration thing. Take everything out, put everything in new. That's a different game from what I play. I play the repair game. Try to do the least possible. Make the radio work again. 80, 90%. Maybe 100 if you're lucky. Maybe 110. Ooh, it can happen. But without changing everything. Try to leave as much in as possible. It's pretty much a guaranteed all the capacitors got to go, and that's what makes this one a problem. Would it be wise to turn this radio on the way it is? Well, not yet. Because we don't know about the tubes yet. So I would like to hunt down the tubes. So there's a sticker on the back here. Tektron timer switch rating. This is just the sticker here. It's just about the clock. What about the tubes? It's all written in this piece back here that can't be read. Better find something like what model is this? I don't remember seeing a plate on the back. Got the serial number, maybe the model number is written in here. Quite likely. Well, I gotta see what I can do about recovering the print that's on here. That might just mean staring carefully at it. Now, if I put this face down and kind of laying it on the clock, that's not so good. Oh, there's a... Oh! Did I see a hole? Right there. There's a tear right there. It's probably a finger thing, not necessarily though. There's also a crack right in here. These things develop radial cracks out here on the outer perimeter. You can see one here. It looks like there's something happening there. All kinds of bad things happen to these very fragile cones. But this one looks like to be in good shape. And just patch that. Patch that and that a little bit. I think we'll be golden with that. So, question. Can this radio be made to work? Well, I think the answer is almost certainly yes. Is there anything in it that would stop it from working? I have to throw it away. Well, defects in the IF transformers. Overcoming problems in this thing is a little bit different, a little bit challenging. Hey, what is this control doing? So it's a series, it's just in series. It's not a potentiometer, it's a variable resistor, the way it's wired. That's a brown, red, orange, so that's 12K. That's a fair size resistor. It's coming from what is probably the ground terminal of the volume control. It's just a ground point. They could have put this wire somewhere else. It's not hooked up to the volume control, so to speak, I don't think. This green wire connects to this tube terminal, which connects to this point, which connects right to this power wire. So I'm going to guess there's some kind of light in here. You can control the brightness of it with this. And there's something special about it because it had a special name. Where is that? What is this material now? Is this metal? This isn't metal. Doesn't it? The light is built right inside that. So there's a clip here. Well, that's got a wire on it. And there's a clip here with a wire on it. Wow. So it looks like you're making some kind of a connection here and here to the analescent lamp. I'm going to have to look that up. Analescent lamp. Incandescent. Analescent. Adolescent. Analescent. Well, I'm going to look that up right now. Find out what that is. Well, I typed analescent into Google, analescent lamp. Absolutely nothing on it. The word doesn't exist according to Google. But there it is. Written right there. Maybe I'm missing some letters at the front, but how would the letters be missing? I did notice this little dash mark down here, which is probably the start point for the pointer. This is some kind of distortion here. There's another one up here. It's either a chip or a manufacturing thing. Maybe this is not within view. They allowed it to go by. It's got these plastic parts, but these, wow, pop those off. You're liable to break them for sure. Well, I think maybe there's a fluorescent tube inside here. How can that work? It can't really work. Fluorescent, I don't think you can power that with a little volume control level thing. I don't know, that's a curiosity. That's kind of neat. How am I going to find a schematic for this guy? Let me look at the cabinet again. Any fancy name here? Sylvania. Sylvania. I don't see any hint. I don't see that there was any sticker ever on the bottom. There's nothing, looks like nothing ever was inside here. They're keeping it a secret. A secret. Oh my gosh, there's a million 5-tube radios out there. The basic circuit layout of this radio is going to be nothing special, let's put it that way. It's got two capacitors here. One is for the local oscillator and the other is for the antenna. You can see the antenna is hooked right up to it. The antenna is forming a coil. The coil and the capacitor combined give you a resonance. This is a big part of the tuning system of the radio, the proper antenna and the capacitor. So if the antenna wasn't around, you'd have a tough time with this radio. But beyond that, that's the only really tuned circuit in the radio. So the output's got to be going straight to the mixer tube, and then it's being mixed with a local oscillator to give the IF frequency. So this is probably the mixer tube. Well, the rectifier sitting here just doesn't look right to me. Can we see underneath? That would really be a lot better if we had the... So the rectifier tube is going to have power wires coming to it, I would think. Let me see something right from this power terminal right to the tube through a resistor. I think I see another star ground terminal. It's buried under these wires here. It looks like there's a terminal here that's right off the chassis, and then I see a whole bunch of stuff going to it, literally in a star pattern. So there's some funny things done with these radios in terms of how the chassis is handled. With this capacitor, a resistor, which may well be one of these. And then a few other things can be connected and grounded to the chassis, but the rest of the radio is not. I find that just a little hard to understand still. But if I waited until the day came where I knew everything about everything, well, that day is never coming. That day is never coming. If you think about the amount of stuff we know, especially when you get a little later in life, you really do know a lot of stuff about a lot of things. You really do. But no matter what, our knowledge as human beings, and would be true of anything, our knowledge is limited. But the universe is unlimited when it comes to things that could be known. So, no matter how hard we strive, our limited knowledge is a pittance compared to what's out there in the universe, which is kind of, a little scary, but also a little bit of good news. We're not going to run out of stuff to learn as a species. I must find a schematic and must resolve the tubes somehow, one way or another. Just looking at it, I certainly could make a mistake. At the moment, it looks like, yeah, this is where the rectifier should be. But we just can't be sure. Just can't be sure. Now, what if the tubes are in the wrong positions? Well, it's a gamble. What's going to happen? Certainly the designers didn't sit and go, well, now if somebody plugs the wrong tubes in the wrong place, we got to design this radio so nothing will fail or nothing bad will happen, especially if the rectifier tube goes in the wrong place or a tube inappropriately goes into the rectifier spot. No one's thought about that, so it's just a gamble as to what would happen. To power this up with tubes in the wrong spot. Now, the previous owner did that. He reported one tube not lighting, the other one's lighting. I don't know how that can happen. These are all in series, I'm pretty sure. How can they not be in series? There's no power transformer. It's clearly a 5-tube radio. What's this little grievance here? This is what's left of the original schematic. Just stretch that out and read it. Well, I think that's the observations I need to make. Must find the schematic. It would be reasonable to pull all the tubes out, turn the set on, and see if the clock works. That's a reasonable thing. There's not much risk in doing that. Once all the tubes are out, the risk is putting them all back in wrong. Hey, that's a real risk with me. Okay, I'm going to hunt around, see what I can do about finding some kind of schematic. I don't know how I'm going to do it, and then we'll look at trying to see if the clock works anyway. Well, my search turned out to be quite productive. I looked for photographs of Sylvania radios from around the 50s. Found a couple. I then went to, just on the internet, and then I went to a radio museum. Searched for Sylvania radios, again in the 1950s. Looked at the pictures that came up. You can view just pictures if you want on that website. And sure enough, there it was. It's a Sylvania 598. You can see the number here, 598. That's the radio. So bingo, we have this beautiful looking schematic. Wow, it really looks like somebody else redrew this more recently. It's a beautiful schematic. Here, yeah, all my questions are answered. I thought I saw a stringing diagram too. I think there is a stringing diagram. I just need to get another page here. But model variations chart. So we're going to end the video just looking over the schematic here and getting more familiar with it. And tomorrow will be the day to try to actually work on this radio and make it operate. So you see all the tubes are in series. There is a light here No, that's the outlet. That's an outlet, I believe. There's a light. It's just a 47. What about this special light in the clock? I don't see any control here for controlling the light. Well, maybe this isn't 100%. Or maybe there's a note somewhere that says something. So let's just read through all the notes. It says a negative B right onto the on-off switch, right onto the power line plug. So you can see if you plug this in a certain way, this is live right in the radio. Hot diggity dog. And this is a typical tube lineup. 35W4, 50C5, 12, 12, 12. You add those up, you get around 117 or something like that. 115, 120. Variations in the different models. Phono input socket. There's no phono input socket on my 598. So they've stuck a resistor in or something like that somewhere. They interrupted this part of the 598 to create the 518. 518 is a smaller number. Older radio. Showing different coils, how they're wound, how to position them. There's like a little dot to sort that out. Audio detector plate. So I think this is the thing I called a package. Oh my gosh, it hasn't got this printed circuit. Oh, printed circuit. Really? All this stuff is in that little package? Ay, 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 ay. Everything in here. So lots could go wrong inside this guy here. And if you wanted to build it up externally, I think you could, but wow, it's a lot of stuff. What's this? C11 with a little asterisk. Combined value of C9 and C11 equals 250. So I think they're telling you that because you can attempt to measure it, I guess, from outside. And so, I don't know. We'll worry about that when the time comes. There's the two filter capacitors, 40, just like we saw in there. WL, so this is a tube. That's the rectifier tube. Just a little bit of an odd way of showing it. This bent here, bend. Just looking for notes. Built-in antenna. Kind of built-on antenna. In some 548, some and B598 models only. Something going on there. Oh, here we are. Panalescent. Panalescent. So there is a letter. It's not analescent. It's panalescent. Panalescent unit. It's a unit. Well, that explains it. There's a unit in there. A panalescent unit. There's the resistor. Or the variable resistor. Okay, so I'll look up panalescent and see what we can find out about that. Clock, power line plug. See partial schematic for 518. Appliance outlet on 598 only. Generally speaking, they put these plugs on the back. So when you go to plug the radio in and you're forced to unplug your lamp because you've only got so many plugs in an old house, you, presto, have another plug to plug your lamp back in. And some of these, the lamp will operate with the clock too, but I don't think this one's like that. Okay, all these notes. Voltages measured with a Sylvania polymeter. Wow, we got to get one of those, that's for sure. Coil resistances are average values. Voltages or resistances not shown where too small or widely variable. What do they mean by that? Widely variable. Intermediate frequencies 455, combined value, designates connection to chassis. Okay, so let's take a look at this. what all is on the chassis. So this is probably that capacitor I was talking about right here. Over here in the front end we might find, here's some more. Oh, these are the cans that go around the IF transformers, right down solid. They're not always grounded to the chassis. The odd radio, this can will be isolated from the chassis, and a wire will come to it to ground it to some special place in the radio. So I don't fully understand all that, but that can be the case. Audio detector plate. Printed circuit. Okay. I don't know what this means. Audio detector plate. This? They're talking about this wire? Which goes to the plate of the audio detector? It doesn't really. The audio detector is more of these diodes. I don't know. There's the tube lineup. There's the tube positions. You can see the 50C5 is the 50C5. Well, that's the output. Okay, this is just looking from underneath. Where are we looking here? Speaker and clock unit. So this must be with the radio flipped upside down. That's how come you can see this capacitor here. So looking from underneath, we have the rectifier out on this end. Yeah, that's where it is. Okay, so my concern was false concern. But here I can make sure the right tubes are in the right place. There's the volume control stuck out the side. Now, like, why would they do this and not stick it out the front, like you would expect? This is showing some of the major components, or maybe even all of them are showing on here quite nicely. So you know where's C12? There it is, right there. Station selector. Well, what are they talking about here? Station selector. That's not how this is done. On my radio, so on this radio there's no front knobs for the radio, they're on the sides. But on my radio this is turned to face in the direction of the speaker, like it faces out front. And this doesn't match at all. This isn't matching. What's happening? The clock is in the middle on my radio. Oh, this must be a different one of these other models or something like that. There's nothing more to show here. Ooh, okay, so on mine, the clock is in the middle. The speaker, if this were flipped over, would be over here. So they just put the speaker on the side and the clock in the middle. And this capacitor is turned forward. Or turned, anyway, turned so the knob sticks out the front. I have a couple other radios with a knob on the side of the radio, and I just think, wow, couldn't they get it out the front? Why did they stick it on the side? Is there anything else here we can gather from here? Anything I missed? I don't think so. So, oh my gosh, my phone is here. Shame. Okay, sorry if you've been hearing some clicks and pops on the video. My phone's sitting right there. Well, that's good. We've got all we need to work on this radio and get it operating. I'm really very, very hopeful now that it can operate. I find the stringing guide too. So, well, thanks a lot for watching, and tomorrow I'll actually do something to this radio. Great. See ya.